Hi, this is Rick for EDU Mobile. Welcome to the iOS 8 development course. This is a large course, longer than any course we've ever done before. And the subject of this discussion is just to kind of introduce you to the course, tell you what you're going to need, and so forth. So let's get started. Okay, first of all, what are you going to need? You're going to need an Intel Mac running OS X version 10.9.3 or later. You will need Xcode 6. This is a free download from developer.apple.com. I suggest that you have some familiarity with an object-oriented programming language, but some familiarity with something like C++ or Java or Objective-C is good. For testing on an actual device, you're going to need an Apple iOS developer account, and you can get one of these $99 a year at developer.apple.com/register/index.action. And this, you can register for an iOS developer account. It costs $99 a year, but you're allowed to test on an actual device. You are allowed to submit apps to the App Store, which after all, I guess is the point of learning how to program for iOS 8 and so forth. So what does the course look like? The course at this point consists of 16 units. There will be at least 16 units. I've already made a change from the published information on the website. I've split the Swift programming language unit into two parts because it's too big to cover in one week unit. But the course basically consists of 16 units, and there will be at least that many. The first two units, of course, are about the Swift programming language. Swift is a new programming language from Apple. It is object-oriented. It is the programming language that sort of obsoletes C and Objective-C from the standpoint of Apple's mobile devices and, of course, also on OS X. When I say sort of, Objective-C is still a viable language. We can still write in Objective-C, and Objective-C will be supported as a language to develop iOS apps in for the foreseeable future. But Apple wants us to develop all new code in Swift. The third unit is about layouts and constraints and views and view controllers. There's been some changes from iOS 7 to iOS 8 in how we lay out applications, and we're going to cover these changes and also how to do it from scratch in Unit 3. Unit 4 is about the model view controller design pattern and some of the collection classes that are available to us, analogs for things like NSArray and NSDictionary that are available to us in Swift. 5 covers tab views and table views. Probably 80 to 90% of all the applications that we develop in iOS are based on a table view or a tab view controller. So this is a very important step to learning. Unit 6, we're going to talk about SQLite. We're going to talk about storing your data in a database. There are different ways to store data. We can use a property list. We can use a database. We can have online storage. We can serialize classes using core data and so forth. But Unit 6 is a concentration on how we use SQLite in our applications to store data. Unit 7 is all about threading and operations, and also something called Grand Central Dispatch. How to write good threaded code. Threading is one of those things that developers shudder about when they learn a new language. It is not that hard. What we have to do is learn when to do it and then how to do it successfully. And that's what Unit 7 is all about. Unit 8, all about the camera. That's all I need to say about that. Unit 9 is about the hardware sensors, things like the location sensors, accelerometer, gyrometer, temperature sensors, things like that. Unit 10 is about audio and video. Again, audio and video are very important things to know about when we're dealing with a visual device. Unit 11, core graphics, core animation. Core graphics and core animation are what pretty much everything else except for Metal is based on. These are the pieces in the Cocoa framework that give us a basis for things like SpriteKit and SceneKit and things like that. Speaking of SpriteKit and SceneKit, here they are in Units 12 and 13. Unit 14 covers Metal, which is a very low-level 3D graphics library. SceneKit will get us pretty far in terms of 3D. SceneKit, by the way, has been in OS 10. It is now moved to the iOS framework, or the iOS platform. So this is very good news for iOS developers. When we need a lightweight sort of 3D environment, we can work in SceneKit. When we need the heavyweight Metal, the low-level graphics framework, then we can choose to use Metal, and we'll talk about that in Unit 14. One neat thing about Metal, if you know something about OpenGL or 3D graphics programming in that context, with Metal, we pre-compile our shaders. They're not compiled at runtime. They are pre-compiled. And this, along with the other ways that Metal is structured, gives us up to a 10 times performance boost in the speed that 3D graphics are rendered using Metal over OpenGL on mobile devices. 15 is about best practices, debugging, unit testing, things like that. And then 16, all about preparing an app for the App Store. So each of these units contains 4 basic components. They will contain discussion videos like this one, demo videos where we get to see code and applications being developed in action, and then the source code for all of the demos, and then assignments. I have increased the difficulty, or the difficulty level of the assignments, and I will be giving you more of them. If you've taken a course with us before, be prepared to have more assignments. I think it's very important that we understand what we're attempting to do. And the only way, in my view, in an online course to get that level of understanding, aside from a one-on-one discussion, is for you to have experience doing assignments. And so that's why I'm going to be giving you more and more difficult assignments throughout the course. Thank you very much.